Hello everyone, you're back for more exponentials and logs, video number 3. Now in this video we're going to look at e and this ln function. Now e is one of these exponential curves that does something like this and goes to the 1, and in this case we have y equals e to the x. Now hopefully you remember from before we said e is just a number. E is 2.718 and so on. And it has this special property that dy by dx is also e to the x. So say we select any point. At this point, the y value, for argument's sake, let's say this is 10, it will have the same gradient at this point. So the gradient at this point will be 10 as well. And just remember our other result, if I've got y equals e to the kx, so some kind of number in front of the x, then dy by dx equals k times e to the kx. So the power here remains the same, and this time this kind of constant is put out in front as well. So we've learnt about e. What about ln? Well, ln is simply just a log base e. That's all it is. Okay, so it's the special case of a log that has the base of this number e that we've been talking about. Great, let's move on to an example. So here we've got ln of 3x minus 5 equals 2 minus ln of 3. Okay, so this first example is maybe on inspection, something that looks a little more complicated, but it's just a matter of rearranging the equation. So firstly, I'm going to get all the ln's onto the left-hand side. And then remember, ln is just log base e, so it follows all of our normal log rules. So one thing that I can do is if I'm adding logs of the same base, which this is, then I can multiply what's inside of the logs. So this is going to be, so I'm multiplying the 3 by the 3x minus 5 equals 2. Then I can simplify inside the logs, so this is 9x minus 15 equals 2. And then I can use my inverse function. So essentially I'm raising both sides as a power of e. If you like, I'm kind of doing e to the power of all of this and then e to the power of this. I'm going to jump straight to that result. So raising this side as a power of e has the effect of just removing the ln. So this becomes 9x minus 15, and on the right hand side this just becomes e to the power of 2. Okay? If you're not sure what I did there, you need to have a look at a previous video. And now we just solve this as a normal equation. So 9x equals e to the 2 plus 15. So x equals e to the 2 plus 15 over 9. And I get 2.49 to 3 significant figures. Let's have a look at this next question. E to the x plus 5e to the minus x equals 6. Now, this is a little trick, a specific type of equation that you need to learn how to do. Before we do this, we have to consider a similar but different equation. So something like e to the 2x minus 2e to the x minus 15 equals 0. Now, if I was presented with this, how would I solve it? Well, I can make a little move like so. I've just rearranged those first two terms a little bit, and hopefully you can see that we have a quadratic here. I can labour the point by writing it like this. So I've introduced a new variable y, and I'm going to say where y equals e to the x. Hopefully you don't need that line and you can see what's going on with the blue line. So I've just moved that to the side, out the way, and we can carry on. So I'm just going to solve this thing in the blue like a normal quadratic. So I get e to the x minus 5 times e to the x plus 3 equals 0, just normal factorization. And so this gives me the result that e to the x equals either 5 or e to the x equals minus 3. Let's remind ourselves of the graph of e to the x. It does something like this, and as you can see, so this is y equals e to the x, and so e to the x cannot be negative. This curve never goes below the x-axis. So I've got my answer, e to the x, and one more step, ln of 5. I've ln'd both sides, and that's my final answer. And I can actually just leave that like that. Okay, so going back to our equation, I'm just going to kind of bring it down here. What about something like this? This doesn't look quite the same, does it? But do you remember before we had an e to the 2x, which enabled us to treat it as a quadratic? So what can I do? Well, there's another little trick that you need to learn. and that is multiplying everything by e to the x, and we're going to do this in order to make it into a quadratic again. Okay, that's our aim. So I've multiplied every term on the left hand side and the right hand side by e to the x, and now I'm going to simplify this, and now bringing everything all onto the left hand side, I get e to the 2x minus 6e to the x plus 5 equals 0. And now I've got my quadratic, and I can begin to factorise this. So I get e to the x minus 5 and e to the x minus 1 equals 0. So my solutions are e to the x equals 5 or e to the x equals 1. For my first solution, if I learn both sides, I get x equals ln of 5. For my second solution, you can look at that and hopefully know that if e to the x equals 1, then x equals 0 straight away. But to labour the point, I can learn both sides and I get x equals ln of 1, which we know is 0. And we're done. Thanks very much, everyone.